In this video, you will learn when and how to apply differentiation of implicit functions. Also, you will learn 3 methods, but most often 2 methods of solving implicit functions. When do you apply implicit differentiation? Let's recap. You apply product rule when 2 functions are multiplying. Subsequently, you can observe that y is separated from x by the equal sign, and we use this formula to differentiate product rule problems as long as the 2 functions are multiplying. For quotient rule, you apply quotient rule when 2 functions are dividing. For example, this function is dividing this function. Hence, we apply quotient rule. And this function is dividing this function. Hence, we apply quotient rule using the quotient rule formula as long as the both functions are dividing. Subsequently, you apply chain rule when 1 or more functions is chained to another function. For example, this is supposed to be sin x. However, this function is now chained to this function, replacing x. Likewise, this is supposed to be cos x. However, this function is chained to this function, and all these functions are now chained to this function, replacing x. Likewise, this is chained to this, and everything here is now chained to sine. Here, instead of x squared, you can see that everything here is now replacing x. Also, for each, y is separated from functions of x by equal sign. 1 and 4 are examples of one inner function, while 2 and 3 are examples of double inner functions. For implicit differentiation, when the functions of y and x are not separated by the equal sign but are mixed together in a question, then you apply implicit differentiation, as we are going to see in this video. Next, how do we apply implicit differentiation? Let's consider this question. To solve this problem, the first step here is to make y the subject. That is, this minus y will move over to the other side and become plus y, while minus 3x squared will move over to the other side and become plus 3x squared. Next, we can rearrange this. Next, let's differentiate. Differentiate 2x and you're going to get 2. Next, differentiate 3x squared and you're going to get 6x. And this becomes our answer. Alternatively, we can apply implicit differentiation. Differentiate 2x and you're going to get 2. Next, differentiate y and you're going to get 1. However, whenever you differentiate y, you're going to multiply it with dy dx according to the rule of implicit differentiation. Next, differentiate minus 3x squared, and you're going to get minus 6x. Next, make dy dx the subject. I'm going to leave the 2 here. Next, I will now move minus 6x across to the other side, and it's going to be plus 6x. Next, I will take 1 dy dx across to the other side, and I'm going to have dy over dx. And you can see we got back to plus 6x. The third method is using the shortcut method. We're going to use this formula that dy dx is equal to minus, there must be a minus. With respect to x, divide by with respect to y. To apply the shortcut method, the first thing is to rearrange the given question. It must be equal to 0. Next, apply the shortcut method. At the numerator, we are going to respect only x. Let's differentiate 2x, and our answer is 2. Next, minus y got no x, hence I'm going to ignore it this time around for the numerator. Next, differentiate 3x squared, and our answer is 6x. Next, at the denominator, we'll respect y only. That is, we're going to ignore 2x this time around and differentiate minus y, and our answer is minus 1. Likewise, 3x squared got no y, hence I'm going to ignore it. Next, this minus will take away this minus, and here we got back our dy dx. You can see the 3 methods gave us D. Next, consider this question. It won't be possible to make y the subject in some questions. Hence, we are going to apply implicit differentiation directly. Applying implicit differentiation, differentiate 2y, and you're going to get 4y. However, whenever you differentiate y, according to the rule, you're going to multiply it with dy dx. Next, differentiate 3x squared, and you're going to get 6x. And when you differentiate x, there is no consequences. Next, differentiate 5, and you're going to get 0. Next, make dy dx the subject. I will move 6x across the equal sign, and it will become minus 6. Next, 4y is multiplying dy dx. Hence, if it moves across, it's going to divide. 2 will go into 6 3 times, and 2 will go into 4 twice. Our dy dx is minus 3x divide 2y. Alternatively, let's apply the shortcut method. The first step is to rearrange the question so that it will be equal to 0. Next, differentiate by applying the shortcut method formula. At the numerator, we're going to respect functions with x only. Hence, we're going to ignore this because it got no x, and we're going to ignore this because it got no x. Let's differentiate 3x squared, and we're going to get 6x. Next, at the denominator, let's differentiate 2y squared, and we're going to get 4y. 3x squared got no y, hence I will ignore it. and this got no y as well. I will ignore it. Simplifying our result, we're going to get minus 3x divided by 2y, and this is our dy dx. From the options, our answer is A. Next, let's differentiate this function, and when we get the answer, we're going to substitute x is equal to 1 and y is equal to minus 2 in the dy dx. By implicit differentiation, differentiate y, and you're going to get 2y. However, because we differentiated y, we're going to multiply it with dy dx according to the rule. Next, 3x is multiplying y, hence we're going to apply product rule. So 3xy. Here I'm going to keep 3x constant. Next, we're going to differentiate y, and we're going to get dy over dx. Next, in product rule, we now introduce a plus. Next, I will keep y constant. Next, I will differentiate 3x, and I'm going to get 3. The differentiation of this is this. Next, differentiate x to the power of 3, and your answer is 3x squared. Next, differentiate 1, and you're going to get 0. Next, differentiate 0, it is 0. Next, open up the bracket. Next, we're going to keep dy dx on this side and its coefficients, while we take this across to the other side. Next, we're going to factorize dy dx on this side. Next, make dy dx the subject, and this is our dy dx. However, we were given a condition that at dy dx, x is equal to 1 and y is equal to minus 2. Hence, wherever I see x, I'm going to put 1, and wherever I see y, I'll put minus 2 in our dy dx. Next, simplify your result. Next, 3 divided minus 1 is minus 3, and this becomes our dy dx. Using implicit differentiation, applying shortcut method, this is already arranged to equal to 0 with respect to x at the numerator. This doesn't have x, this got x, hence I will differentiate 3x and I'm going to have 3. The remaining y, I will just leave it attached to the 3, ignoring it. Next, I will differentiate, and my answer is 3x squared. Next, at the denominator, I will respect y. Differentiate y to the power of 2, you're going to get 2y. Next, I'm going to differentiate 3y, ignoring x. If you differentiate 3y, you're going to get 3. However, because this x is multiplying, I'll just leave it attached to the 3. Next, expand the bracket. This minus will multiply 3y, and you're going to get minus 3y. Next, this minus will multiply plus, and you're going to get minus 3x squared. Next, you're just going to have 2y plus 3x. Next, substitute for x is equal to 1 and y is minus 2 into dy dx. And with the shortcut method, we got minus 3. From the options, our answer is B. Next, let's find the derivative of this function with respect to x. The first step is to restructure the question, which is now this. Before we continue with the solution, let's recap. Log x to base e is the same thing as the natural log of x. When you differentiate log x to base e, your answer is 1 over x. Likewise, when you differentiate the natural log of x, your answer is 1 over x. Likewise, if you differentiate log y to base e, your answer is 1 over y. Also, when you differentiate the natural log of y, your answer is 1 over y. At times, when the e is omitted, that doesn't mean that is not there. Always remember this. In the options, I can see that log x was used. And even though the exponential was omitted, know that it was omitted as long as it is derivative. To solve this problem, take the natural log of both sides. Let's recap. This is equal to this. Likewise, this is the same as this. That is, this is the same as this. Just as this is the same as this. Remember, I just let out the exponential. With this in mind, I'm going to rewrite this. Now, instead of this, I'm now going to have this. Remember, this is just step 1. Next, apply implicit differentiation to both sides of the function. Next, let's differentiate the natural log of y. From the basic derivative table, when you differentiate the natural log of x, you are going to get 1 over x. However, when you differentiate the natural log of y, you are going to get 1 over y. But since it is y we differentiated, we are going to multiply it with dy dx according to the rule of implicit differentiation. The exception to this rule is whenever you differentiate x. Hence, when I differentiate log y, I'm going to have 1 over y. However, it will be multiplied with dy dx. Next, we're going to differentiate x, the natural log of x. X is multiplying the natural log of x. Hence, I will apply product rule. That is, I will keep x constant. Next, I will differentiate the natural log of x. When you differentiate the natural log of x, you get 1 over x without any restrictions. And here, it's the same thing as 1 over x when this is differentiated. Hence, when we differentiate the natural log of x, we are going to get 1 over x. According to product rule, I'm going to initiate a plus. Next, I'm going to keep the natural log of x constant. Next, differentiate x, and you're going to get 1. You can see on the right hand side, we just applied product rule to this. Next, this x will take away this x. Now we are left with this. Next, make the y dx the subject. We can rewrite this function as this. Both are the same. Next, make the y dx the subject. Hence, y will move to the other side and multiply everything here. Next, we're going to replace y from the given question. But y is x to the power of x. And this becomes our dy dx. And you won't be wrong if you include the exponential base. Also, this and this are the same. And this is our result. From the options, our answer is A. Next, let's find the derivative of this function. When you have obtained the answer, you're going to substitute for x is equal to 1 and y is equal to minus 1. To solve this problem, let's apply implicit differentiation. Here, we are going to apply product rule. Likewise, to this, we are going to apply product rule. X is multiplying y to the power of 5. Likewise, x squared is multiplying y. 5 is multiplying x, however, 5 is a constant and not a variable. Let's keep x constant while we differentiate y. Differentiating y to the power of 5, we're going to have 5y to the power of 4. However, because we differentiated y, we're going to multiply it by dy dx according to the rule of implicit differentiation. Next, we put a plus, which is in the rule of product rule. Next, we're going to keep y to the power of 5 constant, and we're going to differentiate x, and we're going to have 1. We are done with this. Next is this minus. Next, we're going to concentrate on x squared y. Next, keep x squared constant. Next, differentiate y, and you're going to get 1. However, whenever you differentiate y, you're going to multiply it with dy dx according to the rule of implicit differentiation. Next, according to product rule, we're going to put a plus. Next, we're going to keep y constant, this y, and we're going to differentiate x squared. When you differentiate x squared, you're going to get 2x. You can see that this gave us this, while this gave us this. Next, this plus will come here. Next, differentiate 5x, and you're going to get 5. Next, this minus will come here. Next, if you differentiate 3, which is a constant, you're going to get 0. Next, differentiate 0, and you equally get 0. Next, you open up the bracket. Beware of this negative. Minus multiply plus will give you minus. Next, the variables without the y dx attached to them will move over to the other side of the equal sign. Next, if this move over, it will become a plus, and if this move over, it will become a minus. and if plus 5 moves over, it becomes minus 5. Next, factorize dy dx out. Next, make dy dx the subject. When we move this across, it will divide. Hence, this is our dy dx. However, from the question, we are given that x is equal to 1 and y is equal to minus 1. Wherever I see x, I'm going to put 1. And wherever I see y, I will now put minus 1. 2 multiplied by 1 multiplied by minus 1 will give you minus 2. Minus 1 to the power of 5 will give you minus 1. And minus 1 to the power of 4 in bracket will give you 1 multiplied by 5 will give you 5. Next, 2 here is 3 while 2 here is 2. And this is our dy dx. Next, alternatively, using the shortcut method and applying this formula at the numerator, we're going to respect x for each variable. Let's differentiate x here is going to be 1, but we're going to ignore y to the power of 5. Next, in the next variable, I will differentiate x squared and I'm going to have 2x. However, I will ignore y. Next, I will differentiate 5x and I'm going to have 5. Next, if you differentiate minus 3, it is 0. Remember to put it in bracket because of this negative, which is in the formula. Next, we consider the denominator with respect to y. We're going to differentiate y to the power of 5, and we're going to have 5y to the power of 4. However, we're going to ignore x. Next, let's differentiate y here, and our answer is going to be 1. However, I will ignore x squared. This got no y, and here there is no y. And this will become our dy dx using the shortcut method. Next, you open up this bracket with this negative. Substituting for x equal to 1 and y equal to minus 1. This is our dy dx. From the options, our answer is C. Next, let's differentiate this function. And after we obtain dy dx, we're going to substitute x is equal to pi while y is equal to 1 to the final result. To solve this problem, let's apply implicit differentiation. In the front of sign, we have xy, and we're going to differentiate this using product rule. However, differentiating the entire function will be chain rule. While to differentiate this, we are going to apply product rule. But the entire function is implicit differentiation. This is 2 pi. It got neither x nor y. Step number 1. We're going to differentiate xy. We're going to keep x constant and differentiate y is going to be 1. However, we're going to multiply that with dy over dx according to the rule of implicit differentiation. Next, according to product rule, we have a plus. Next, we're going to keep y constant. And when we differentiate x, it's going to be 1. We are done with xy. Next, let's differentiate sine. And we're going to get cos. Next, we're going to recopy back x and y according to chain rule. Now we are done with this and have obtained the derivative. Next, this is plus, hence I'm going to have plus here. Consider 2x multiplied by y squared. I'm going to keep 2x constant. If I differentiate y squared, I'm going to have 2y. Because I differentiated y, I'll multiply it with dy dx according to the rule of implicit differentiation. Next, I will put a plus. Next, I will keep y squared constant. When I differentiate 2x, I will get 2. The differentiation of this gave us this. Next, let's differentiate 2 pi. Here, there is neither x nor y. Hence, when you differentiate 2 pi, it is 0. Next, we open up the brackets. Next, this will multiply this. Likewise, this will equally multiply this by distribution. This multiply by this. You will get this. Next, y multiply by this, and you're going to get this. And everything here remains the same. Next, this without dy dx and this without dy dx will move over to the other side of the equal sign. Next, factorize dy dx out. Now that we have factorized dy dx, next, make dy dx the subject. Hence, this is our dy dx. Next, we're going to substitute for x is equal to pi and y is equal to 1 into our dy dx. Next, now that we have obtained our dy dx, wherever I see x, I'm going to put pi, and wherever I see y, I'm going to put 1. Next, pi in front of a trigonometric function is equal to 180. Hence, cos pi is the same thing as cos 180, and cos 180 is equal to minus 1. However, pi outside a trigonometric function is not equal to 180. It remains your usual 22/7 or 3.142. Hence, this is equal to minus 1 and this is equal to minus 1. Next, let's simplify our result. Minus 2 plus 1 is minus 1. And minus pi plus 4 pi is 3 pi. And this is our dy dx. Next, alternatively, let's use the shortcut method. First, let's consider this. However, my concentration now will be at x. Let's differentiate x. We're going to get 1. However, I'm going to ignore y. Next, we're going to differentiate sine, and we're going to get cos. Next, I will recopy back the x and y in front of the sign. Now I'm done with this. Next, I will put this plus. Next, in this function, I will differentiate x and I will have 1. However, I will ignore 2y squared. Because of the presence of this negative, everything here will be in brackets. If you differentiate 2 pi is 0 because it contains neither x nor y. At the denominator, I'm going to differentiate y and it's going to be 1. However, I will ignore x this time around. Next, differentiate sine and I'm going to get cos. And I will recopy back xy in front of the sign. I'm done with this. Next, I will include this plus. Next, I will differentiate y squared and I'm going to get 2y. However, I will ignore the 2x. Next, we simplify our result. Next, wherever I see x, I will put pi, and wherever I see y, I will put 1. Respecting the condition from the given question. Next, cos 180 is minus 1 and cos 180 is minus 1. Because pi in front of a trigonometric function is equal to 180. Solving carefully, we obtained minus 1 divide 3 pi. From the options, our answer is A. Next, let's consider this question. The first step is to rewrite this question. Next, we are going to differentiate this using chain rule and differentiate this using chain rule. However, we are going to respect product rule here with the xy in front of the cos. Next, bring down these two. Next, differentiate y and you're going to get 1. However, whenever you differentiate y, you're going to multiply it with dy dx. Next, differentiate sine and you're going to get cos. Next, recopy back the y back to the front of the cos according to chain rule. Next, the 2 at the top will minus 1 according to the general rule for differentiation. Next, we put this plus. Next, let's differentiate xy in front of this cos. I will keep the x constant. If you differentiate y, you're going to get 1. However, whenever you differentiate y, you multiply it with dy dx. Next, according to product rule, I will put a plus. Next, I will keep the y constant and I will differentiate the x, then I will have 1. We differentiated this using product rule and we got this. Next, let's differentiate cos. From the basic derivative table, when you differentiate cos x, you're going to get minus sine x. Hence, I'm going to get, if I differentiate cos, I'm going to get minus sine. Next, I will recopy back xy back to the front of this sign according to chain rule. Next, if you differentiate 1, you are going to get 0. Next, open up the brackets this multiply by this will give you this. Likewise, this multiply by this will give you this. Next, the variable without dy dx will move over across the equal sign. This will move and become plus on the other side of the equal sign. Next, factorize dy dx out. Next, make dy dx the subject. Because this is multiplying, if it moves across, it's going to divide. And this becomes our dy dx. Alternatively, let's use the shortcut method. Let's rearrange the given question. Next, let's find the dy dx using the shortcut formula. At the numerator, let's respect x. Here, there is no x. We have sin y squared. Next, I will consider this. Here, we got an x. Differentiate x, it is 1. However, I will ignore y. Next, differentiate cos, and you're going to get minus sine. Next, you recopy back the x and y in front of the cos according to chain rule. Next, at the denominator, we are going to respect y for the entire function. Here we got y. Hence, the 2 at the top will come down. Next, differentiate y, and you're going to get 1. Next, differentiate sine, and you're going to get cos. Next, recopy back the y. Next, the 2 at the top will minus 1 according to the general rule for derivatives. Next, we now consider this. Here we got y. Differentiate y, and we're going to get 1. However, I will ignore the x at each side. Next, differentiate cos, and you're going to get minus sine. Next, you recopy back xy in front of the cosine. Next, we simplify our result. Solving carefully, this is our dy dx using the shortcut method, which is same as we obtained earlier. From the options, our answer is B. This is calculus. In the next video, we are going to consider the differentiation of parametric functions. These are recommended video topics in differentiation, and also some suggested video topics in integration, including their applications, including PRECALCULUS video topics. To locate all these videos, follow the link on the screen. I will see you in the next video.